Namaste and welcome to Apna Gurukul Maths. And this is the third video of the chapter Triangles, which is chapter number 7 NCERT class 9. And we have already discussed ASA and SAS rule. Plus, we have discussed two of the properties of triangles, that is equal as the sides opposite to equal angles are equal, and the converse of this. I hope all of them are clear. If you have not seen those, you can just go in the description, look at the playlist of triangles, and you can go and visit that. Now, criteria for congruence, some more criterias we have to study. We have already studied ASA and SAS as we already stated. Now, the next criteria which we have to focus on is the SSS rule. What is the meaning of SSS rule is, if you have two triangles and all the three sides of one of the triangles are equal to another side of the triangle, then two triangles are said to be congruent. Very easy. Similarly, theorem 7.5. Now, how will we, if you want to see an example, you can just visualize, like, suppose you have two triangles and one of them has a side length of 3, 4, and 7, and over here also 3, 4, and 7. Yeah. So both of them, all the three sides are corresponding to each other, and that's how we get this SSS congruence rule. Now, theorem 7.5, as you can observe right now, it says it is very, very much important. Now, this one is valid only for a right angle triangle. What does it say is, if suppose you have two right angle triangles, and then in these two right angle triangles, the obviously right angle will be equal. If suppose the hypotenuse is also equal, okay, ABC is one of them and DEF is the other right angle triangle. Obviously, they are making a right angle at B and D. Hypotenuse is also equal, and then any one of the side, suppose AB is equal to DE, then we can say that these two triangles are congruent. RHS rule. Right angle is equal, hypotenuse is equal, and any one of the side is equal. Now, why do we prefer one of the side here, and how is it different from SAS rule? Because in SAS also we had two sides and one angle. Over here also one right angle and two other sides we are talking about. But how is it different from SAS? In SAS, the angle must be included. Over here, as you can see, right angle is here. The included angle is A and D. But that need not be, means that we doesn't require. If we have a right angle triangle and hypotenuse is equal and any one of the side is equal, then we are done with the proof. Why is this so? Why is this so? Because according to Pythagoras theorem, if two of the sides are equal, the third must be equal. We don't have other choice in that. Okay, so indirectly it is an extension of SAS rule. We can say that. I hope that makes sense. If you can go through this statement, if you want to go through, you can pause the video and go through it. Let us now solve few example related to that. Example number 7, as you can see, it's talking about AB is a line segment. AB is a line segment. PQ are points on opposite side of P and Q are on the opposite side of AB. One is on top and the other on bottom. It is in such a manner that it is equidistant from point A and B. That means from A if you travel to P, that is AP. From B if you travel to P, BP. Is AP and BP are equal. So it is given as AP is equal to BP. Similarly, from A if you travel to Q, that is equal to AQ is equal to BQ. I hope that makes sense. Now what do we have to prove? We have to prove that PQ is perpendicular bisector. PQ is the perpendicular bisector of AB. Yeah. So what exactly do we have to prove? If it is a perpendicular bisector, then over here it must make an angle of 90 degree. And since it is also talking about bisector, we must prove that C is the midpoint. What do we need to show if C is the midpoint? That AC is equal to BC. So to prove, we have to prove two things. AC is equal to BC, and then angle PCA is equals to angle PCB is equal to 90 degree. That we have to prove. Let us understand how can we approach the proof. Now somebody of means that happens generally. You might be thinking to take these two triangles, and then this is the common side, this is the common, this is the equal angle, so these two angles are equal. We can use SAS rule. If you are thinking that, then rethink your decision. Why am I saying that? It's because when you observe these two triangles, APC and APCB, you talked about these and this side to be equal perfect. PC is common side perfect. Angle means PAC and PPC is equal, but we cannot use SAS rule. Because SAS rule, the angle must be included in the two equal sides. Two equal sides are these, right? We must be talking only about this angle. If this angle is equal somehow, then we can say use SAS rule. So for that, we need to think a little bit extra. Okay. So for that, what we will take is, we will take the two triangles APQ and PBQ. Listen very carefully. AP is already equal to PB, and it is already given AQ is equal to BQ. Yes or no? At the same time, PQ is the common side. That means using SSS rule, we can say that triangle APQ is congruent to triangle BPQ. I hope that is very much clear. So can I now say that angle APQ is equal to angle BPQ by CPCT, right? So by CPCT, I have shown that these two angles are equal. Now we can again do what we started with. We started with looking for these two triangles, APC and PCB. Yeah, it's not Pakistan Cricket Board. PCB is just a name given over here. Now you can observe AP is equals to PB. These two triangles we have already proven that these two angles, that is APC and BPC, we have already shown to be equal due to corresponding CPCT, and then CP is the common side. Now you can use SAS rule. With the SAS rule, you can state that triangle APC is congruent to triangle AP is equal to BP and then C, BPC. And according to this, you can very easily say that AC, which is the at the end, right, is equal to BC again by CPC. Now, half of the part we have already proven. Okay, half of the part, that is AC equals BC, we have proved it. Now we are left with proving it as 90 degree. That is what we have to prove. Now, since according to this congruence, angle PCA is also equal to angle PCB. Yes or no? They are equal by CPCT once again. And at the same time, so I'll mark both of them as X and X. Now, as you can observe, since ACB is a straight line, these two angles, that is X plus X, must be 180 degrees. That is equals to 180 degrees by linear pair. I hope that makes sense. See how everything is connected. So 2x equals 180 degrees. So x must be, 2 comes down, so x must be 90 degrees. So this is 90 degrees. I hope that makes sense. We have already proven that they are 90, and AC is equals to BC. We have already shown by CPCT. We are done with the proof, so we can state that. Therefore, line PQ is perpendicular bisector of AB. My dear friends, do you observe one more thing over here? This figure is actually a kite. And what we have shown right now is that the diagonals of one of the diagonals of a kite is perpendicular bisector to the other diagonal. Now, AB is not a perpendicular bisector. AB is intersecting PQ at 90 degree, but it is not bisecting because PC is not equal to CQ. I hope that is clear. Okay, let's move on to the next question. Example number 8, what we have. P is a point which is equidistant from line L and M. So L and M are two lines which is intersecting at A. And then we have P is a point which is equidistant. Now, which is equidistant from, so that is BP is equal to CP, it is given. Yeah. Then what is, then we have to show that AP bisects the angle between them. Like this line AP is bisecting the angle between them. That means we have to show that angle BPA is equal to angle CPA. So we just need to prove the congruence, and then by CPCT it can be shown. So we will consider triangle BPA. Okay, BAP we will take, and we will consider triangle uh, CAP. As you can observe in the question itself, angle B is equal to angle C is equal to 90 degree, it is given. Yes or no? Then we try to think about BP is given equal to CP. This is one of the side becomes equal. And as you can observe, AP is equal to AP, which is common side, and it is also the hypotenuse. So using RHS rule, we can say that triangle BPC is congruent to triangle CPC. And if we have shown that, we can say by CPCT rule that angle BPA is equal to CPA. So therefore, AP bisects the angle which is formed by angle BPC, we can directly tell. I hope that is clear. It's very, very easy. Just need to prove the congruence, and that by CPCT, we are done with the proof. And this is it for this particular video. So thank you so much for being with this video. I hope you learned something amazing. Apply it in the exercise problems of this 7.3. And obviously we'll be doing the exercise, but after we are done with the theory part. I hope you enjoyed a lot. Thank you so much for being with Apna Gurukul Maths. One little step towards success. See you in the next video. Until then, keep smiling. Jai Hind.